Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, understanding the definition of a translation. And I do realize this one is pretty small. I was trying to figure out how to get it to all fit on one page, so bear with me when we get towards the end there. Alright, so translating triangle PQR to the left 5 units and upward 4 units, we get the image triangle P prime Q prime R prime. So we're taking this gray one and moving it to that blue one. So note that the vertices, so they basically give us all the vertices over here. All right, find each length, give exact answers, not decimal approximations. So that means we're going to leave our answers in radicals when we do the distance formula here, or the Pythagorean theorem, however you're going to do it. They're basically the same thing. So leave it in radicals if there are radicals. If it comes out evenly, then it comes out evenly, and that's fine. So you don't have to have a radical. It's just if you do, don't clean it up. Then we'll find the slope, and we'll go through a couple statements based on those. So find the length of P prime, so this length here. So since I have a picture, I'm just going to go ahead and use my Pythagorean theorem. So if I'm looking at this triangle right now. Okay. So this side over here, I'm going up 1, 2, 3, 4. And then I'm going over 1, 2, 3, 4, 5. And then I'm trying to find the length over there. So based on my Pythagorean theorem, it's going to be, this is P prime, is going to be the square root of a squared plus b squared. So 4 squared plus 5 squared. So 4 squared is 16, 5 squared is 25. When I add those up, it looks like I get 41. So I'm going to leave my answer in that radical there as the square root of 41. And I'll do the same thing for Q prime and R prime. So when I look at these ones, Q prime, I'm going up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Sounds familiar? That'll be radical 41 in this case as well. And then R, I'm going up 1, 2, 3, 4. 1, 2, 3, 4, 5. And this is not a coincidence. We're actually building up to some statements around that. So the fact that they're all radical 41 is not coincidental. Okay, so we get radical 41 for all of those. And then find the slope. Well, I already kind of measured this out, so I'm just going to use my numbers there. So I want rise over run, so I'm going up 4, left 5, so rise 4, and I'm running left, so that's negative, so when I clean this up, that's negative 4/5. Q, same thing, because we have the same measurements for all of them, so we get negative 4/5 and negative 4/5 for all of those lines, which, just jumping back, makes them all parallel, right? They all have the same slope. So, all right. And then we're going to choose the correct statement down here. All points on the original figure move the same distance, but not all points move the same direction. So distance is the actual distance there, the length that, and then the direction is determined by your slope. So it says, basically translates to all points moved have the same length, but not all of them have the same slope, and that's false. They have all the same length and all the same slope. That's false. The points on the original figure didn't move the same distance. Okay, well, that's wrong already. All points in the figure move the same distance and in the same direction. That is the one we want. But let's just read the last one to make sure. Move the same distance, but not all the same direction, but not all points move the same distance. So that's false. So they went the same direction and the same distance.